Hey guys, it's EJ with Blockpad. Today we're looking at custom functions. So let's get into it with an example. We're going to press the equal sign to open up just a regular equation. And now I'm going to type in the name of the custom function and then an open parentheses. Then now I'm going to type in the names of my arguments separated by a comma. So here A, comma B, and then a closed parentheses. Then I'm going to press the equal sign and then the function definition using the names of those arguments. So here, the square root of a squared plus b squared, close parentheses. And then I'm going to press enter, and that's it. That's my custom function. So to use it, I'll open up an equation, and then I can type it in, and then type in the values for the argument. So 3 feet, comma 4 feet, close parentheses, and it's going to give me the result. Now I can also click on it to reference it, and then I can type in the arguments, and that's it. I can do math around these just because it's a regular equation. So there's nothing real special going on. You're just going to treat it like a regular function. Now to go back to the definition for a moment, like I said, this is the name. And then these are going to be the names of the arguments that you're going to use in the definition. So if you just want one, you're just going to type in one name. If you want two, you're going to type in a comma and then the second name, and so on and so on. And these names can be whatever you want them to be. So I can say A sub 1, B sub whatever, but then you need to use them in the definition. So here I need to also have A sub 1 and B sub whatever. But notice that my drop down here is going to help you based on what you've typed in there. So I can press tab to put that in and then the equal sign. And this is going to work again the same as it was working before because the math hasn't changed. We've just got these different arguments here. I'm going to press Control Z to undo that. And one final note about the definition here is you're going to just use regular Blockpad formulas to define this. So you can use anything that you can use in a regular Blockpad equation, including things like units intelligence or arrays, or referencing other values in the document, including functions that you've already defined. So to show an example of that, I'll make a custom function called perimeter and say b comma h for base and height equals b plus h plus the hypotenuse of b and h. So that'll give me the perimeter of a right triangle. And I'll press enter. I've got my custom function and I can use it just the same as I was using my other custom function. So that's really the basics. In the rest of the video, I'm going to show you using custom functions in other frames like reports and sheets, and then go through a couple of examples of useful applications. So to use a custom function in a separate report, it's basically going to be the same as referencing a value in another report. So I'll press the equal sign and navigate back to report 1 and click on my custom function. I'll come over here to report 2 and then do open parentheses, and now I can use it just like I was using it earlier. So A1, comma B1, and then I'm going to get my answer that way. Now, if you don't like seeing report 1 here in the front, your first option is going to be to change the name of report 1 to something that you do want to see. So for example, functions. And now I have functions.hypotenuse. And that's how a lot of people will use this. They'll make a report called functions and define all of their custom functions in that report. And then they'll always be using it as functions.hypotenuse. Now, if you still don't even want to see functions, you can go to Properties and Math Layout and change hide namespaces to yes and click OK. And then when you've done that, the functions.hypotenuse will still be in your formula, but in the math display, you'll just see hypotenuse. Now, using this in a spreadsheet is going to be very similar. I'll press the equal sign and then navigate over here. and then the open parentheses, and then I can use these cells as my inputs, close parentheses, and then I can treat this just like anything else in my spreadsheet, and I can format it however you want to. So for common applications and examples, this first one, commonly repeated calculations, I think that's pretty straightforward. Just anytime you find yourself using an equation over and over again, you might want to consider making a custom function instead. But for lookup tables, I have this example here where we have water density and how it changes with respect to temperature. So for my custom function, I use VLOOKUP interpolate, and my argument here, t, is going to be my lookup value. And then I reference the water properties table and use VLOOKUP as usual. So now when I use that custom function, I'm going to get the results of that VLOOKUP. So 25C is going to give me a value between here. 100F is going to do my units intelligence. And down here I have a little calculation just showing using the function in context, just mass equals volume times this row function of T1. And I've got my 2 pounds mass there. Just as a side note, these values here, they do have units intelligence on them. The units are just hidden. So here in value format, I have hide units checked. And then I just make sure to show what units these are here in my label. So for the next example, we have one that I've actually shared with you before in the tables video. And here I have cylinder options where I have an input flow rate and pressure, and then these different options that I want to calculate force push, force pull, and time push on. And instead of having the math hidden behind the cell, in the formula, I'm just referencing this custom function and then passing the arguments into it. And so that way, all of my math is actually out and visible on the page and in math notation. And also, if I ever need to make a change, whether a correction or whatever, I can come just to this function definition. And for example, I can say round up. And now all of my times are rounded up to the nearest second. I'm going to press Control Z to undo that. Then in my next example, I have this transient conduction calculation where it looks at the temperature of a body inside of an ambient temperature and how that changes as it approaches the ambient temperature. So down at the bottom, I have this function, temperature as a function of time. And then I'm able to use it to say, okay, what temperature at 30 seconds, at 30 minutes, at 5 minutes and 30 seconds. And then this is also an interesting use of nested custom functions because here my heat transfer rate is using this temperature function that I've already defined. Now, both this example and the hydraulic cylinder example are in our sample files. So if you come to a blank tab and click sample files, you can see different sample files that we have, including transient conduction and hydraulic cylinder calculate options. So you can take a closer look at how those custom functions are defined. Finally, another great use of custom functions is with inline programs. And you can use these to create these pretty complex procedures and calculations, and then use them as custom functions in the file. So as two examples here, I have this isPrime function, where you put in a number and it'll tell you if it's prime or not. And then also this every other item function, where you put in an array and it'll return every other item from that array. Now, I'm not going to get into detail on how to use inline programs in this video, but I'll put a link in the description, and it's going to include these two examples along with all the basics for what you need to know for inline programs. And that's all I've got. Let me know if you have any questions. Thank you.